Hello everyone and welcome back to another episode of Links Digital online series. Today we'll be looking at computer vision with Python, and for the first 10 episodes of this series we looked at image processing as well as booting up the camera. So for the next few sessions we'll be looking at a different aspects of OpenCV, which is the color space. So all the images we see in color, in grayscale, we're looking at how we can play around with these values and give us different kinds of masking, identification of different forms of color. So OpenCV is able to break down the different colors or even compositions of the RGB values that are present in each frame. Can use it to maybe detect the color of a traffic light, or maybe the color of the hazard lights of cars in front, which is red in color in Singapore. So all these are some things that we can explore with this function. So let's dive into the code. So for the capturing of frame, we'll be using the camera for now. 0 means, just to recap, 0 means we're using the camera that's attached to your device, maybe your computer, your phone, everything. While true means that it just keeps the loop going. For every frame it iterates, it's always true because Python code will run down chronologically. So while true just means true. And then if it's true, which is true, they'll allow the capture, which is the video, to read the frame. So from this, it will give you frame and is successful. So is successful is a Boolean variable, which is either yes, it's either true or false. So if is successful means that if success is successful, it's true. So true will come from a frame being valid. So if there is a frame to display, it will say true. So this comes like a buffer to make sure that if there are any frames that do not load up properly or there's some lag time, it does not crash the whole program. So that's just important for that. And the thing of interest for the next few sessions will be frame. So what frame is actually a matrix. So we have our normal, just look at the screen. So we have the X, the so-called, if you take the point of reference to be the bottom right-hand corner of your screen, we have an X-axis going to your right and a Y-axis going upwards. Right, so what OpenCV will do, or like what frame is it's an array which has 3 dimensions. So first dimension, X-axis, second dimension, Y-axis, and the third dimension is the RGB space. So what it will do is that it has, just treat it as a 3D array. Pretend your screen is like up, to the left, to the right, and inwards. So there's the Z-axis to it, and the Z-axis will be the different compositions of RGB values from 0 to 255. So if you look at the scale of colors, they're all composed of a combination of RGB values. So every color made up of a few, right? So but for OpenCV, the way that it's arranged is B, blue, G, green, and then R. So when we look at our array, it will be like, if you're going inwards, like Z-axis, the first element in the array, there are 3 elements. The first element is B, blue, second is G, green, and third is R, which is red. So we have to be careful when we do our editing later. So let's go into the code, and so we just capture the frame, and if it's successful, then we will need to look at we need to extract the different arrays that we want. So first we do blue. So we just call it blue, and then we'll take frame, which is the original frame. We'll do dot colon. This colon means that you want everything in the array. So colon is because we want everything in the X and the Y-axis. So X-axis just means all the pixels in the horizontal axis, and Y means all the pixels in the vertical axis. So we want them all because we want to find the image, the color composition of the whole frame. So if you want to take like maybe half the frame, then you can edit the array accordingly. So to know how many pixels are there in the x and y axis, you can just do a length. So calculate the length of, calculate the number of columns, calculate the number of rows, and you get it. So for the third one, which is the one of interest, B will be the first one. So just put one there. So next, we will look at green. Frame, colon, and 1, 2. So this just means the second one, second element inside. And then red, blue frame, colon, 2. Right. So for this, it will just give us the array, like the whole matrix will be printed out. And if we want to print it, so like if we want like print red, it will give us the full matrix. If not, we can just do print red too. So let's just see how it is. Let's run the module. So just Python will help you to pick up such errors in terms of like typing. So yes, here we go. Right, so for this, it will just show the different rate values that exist in all the pixels across it. So the first one, 255 here, will just mean the blue composition, the blue value of the top leftmost pixel, top leftmost pixel. So you can see it's white here, right? So it will put 255. So if we put something black over at the corner, see like the number changing. Can't really make something extremely. Alright, so let's do a little experiment. Let's cover the camera and see how the values of the blue changes. So blue is from 0 to 255. White is just 255, 255, 255. But black is different. So let's see what's the value of black. Right. So you can see if you cover the camera, the value goes to very low or 0. So ideally, full pitch black is 0. So yep, you can see the difference in the color. And this prints every frame. So as we did the is successful just now. So while true will print every frame. So every frame that we have, it will keep printing an array, right? So it will go from the top left corner to the bottom right corner again, like I mentioned earlier. So let's just close this. Start shell. Right, and we'll go on to continue our code. So let's not print this anymore. And let's move on to the next part, which is to find the mean value. So what we want to do now is just to play around with the colors. So we'll take the mean value of the full frame and we'll do some RGB, red, blue, green testing. So we'll just cloak it with a green object and then see how it performs in terms of like recognition of the overall color of the frame. So let's go do it. So we'll do that by finding the mean value. So as you can see here, it gives us an array of each individual color. So currently like blue has all these values. So we'll find the mean and see which mean is the highest. And that will mean that the color is most dominant in the frame. So let's just do a simple blue mean. So it will take NumPy. It will use a method in NumPy called mean. So it just helps you to find the mean value. So you pass in blue and it will do the job for you. So we can do the same. Just like this, simple. And then we will want to do some logic to find out which color is the most dominant. So what we can do is this. So let's just do an if loop. We can do an if loop for this. So if blue is greater than green mean and blue mean greater than red mean. So that would just mean if it's greater than if blue is the greatest. We can do it via a for loop in terms of like the values of each. We just like append all the three means into an array, and then compute based on based on a for loop. But I think this will be simpler. So if blue is the greatest, then we'll print this frame is predominantly blue. Let's just print something simple like this. So remember, if you're printing a string, you must always have the inverted commas there. It can be a single. Just be consistent. If it's a single inverted comma in front, it's a single behind too. So next we'll look at green. The green mean is greater than blue mean and greater than red mean. That means frame is predominantly green. Simple. So for the last one, I mean there's only RGB, right? So we'll just put else frame. This frame is, of course this is not a good assumption, because I mean there's so many colors out there. It could be a totally dark frame, a black frame, and then it will just give like nothing. So okay, how about we do this? If this will be if. So how about we do something that says if green less than is it 30? Dark. So it just means that the frame is dark because it's mainly black or dark colors. So let's run this module. Fine. Alright, so looking back at our code, we made a mistake on top. So initially, the colon wasn't here. It's supposed to be a colon for blue, so it's everything to 1. Then it's 1 to 2. Last one is 2 to everything. So with that, it will work already. So let's look at how this runs. There's no change to the rest of the code for that. Right, so if this frame is showing red, let's draw something. This it will say green, and then if we have something blue, not really blue, we say blue. So that's how we will do it, and then this will be good for if we look at a certain region of interest only, not like the full frame of it. So that's when we will manipulate the values of the first and the second element of these two arrays, and then that will give us a bit of flexibility to carve out a certain area, not just display the whole frame. So we also can look at how you can do bounding boxes of certain areas that are of a certain color. So we don't just blanket the whole frame that we have. So that's something we'll look at in future sessions, and this is just a taster to what RGB values are and how are they displayed or recorded in NumPy arrays. Right, so that's the end for today's session. If you're looking for the code for today's tutorial, you'll find them in the description below. And till then, see you next time.